Imagine receiving a message tomorrow. Scientists have confirmed that Proxima B contains liquid oceans, breathable air, and unmistakable signs of life. The greatest discovery in human history. The entire world celebrates. Governments mobilize. Space agencies announce emergency programs. Humanity finally knows it is not alone. But after the excitement fades, one question remains. Can we go there? The answer is both inspiring and devastating. Because Proxima B is close enough to transform our future, and far enough to make that future almost impossible. Just over 4 light-years from Earth, Proxima B orbits a small red star known as Proxima Centauri. On the scale of the universe, that distance is practically next door. In everyday terms, however, it is almost incomprehensible. Light itself, the fastest thing in existence, requires more than 4 years to complete the journey. Nothing humans have ever built comes remotely close to that speed. Not even our greatest machines. To understand the challenge, think about humanity's greatest voyages. The moon sits roughly 384,000 kilometers away. Apollo astronauts reached it in only a few days. Mars is vastly farther, tens of millions of kilometers from Earth depending on its position. Yet even Mars remains inside our cosmic backyard. Proxima B is different. The gap is so enormous that if Earth and the moon were separated by a single step, Proxima B would be thousands of kilometers away. The numbers become so large that they stop feeling real. More than 40 trillion kilometers separate us from the nearest potentially habitable world. Now consider speed. Voyager 1 is the fastest spacecraft ever sent into deep space. For decades, it has traveled farther than any human-made object. Even so, it moves at only a tiny fraction of light speed. At its current velocity, reaching Proxima B would require roughly 76,000 years. Think about that for a moment. Entire civilizations rise and fall in just a few thousand years. Languages evolve. Empires disappear. If a spacecraft left Earth today at Voyager's speed, it would arrive in a future so distant that everything we know today would be ancient history. This is where many people assume the solution is simple. Build a faster rocket. Unfortunately, physics disagrees. Every rocket carries fuel. But fuel itself has weight. That weight requires more fuel to move it. And that additional fuel requires even more fuel. The problem grows exponentially. Eventually, a rocket becomes mostly fuel carrying even more fuel. This limitation has haunted engineers since the dawn of the space age. Chemical rockets took us to the moon and may one day establish colonies on Mars. But when the destination is another star, chemical propulsion begins to look hopelessly outdated. Distances that seem enormous within our solar system become insignificant compared to interstellar space. Scientists have therefore explored more radical possibilities. One proposal uses nuclear thermal propulsion. Instead of relying on chemical combustion, a nuclear reactor heats hydrogen to extreme temperatures and ejects it as thrust. The efficiency improves dramatically. Future missions to Mars could potentially take weeks rather than months. Yet even this breakthrough barely changes the equation. Proxima B would still remain thousands of years away. Then comes one of the most controversial ideas ever conceived, Project Orion. A spacecraft powered by nuclear explosions. Not one explosion, not 10. Thousands. The concept sounds absurd. Yet during the Cold War, engineers seriously studied it. The spacecraft would repeatedly detonate nuclear devices behind itself, riding the resulting shockwaves through space. On paper, the design could achieve speeds that conventional rockets could never reach. For the first time, reaching another star within a human lifetime started to look possible. But the political, environmental, and safety concerns were overwhelming. International treaties and public opposition ensured that Project Orion never advanced beyond theoretical studies. Perhaps the most promising idea today doesn't use fuel at all. Instead, it uses light. Every photon carries momentum. Normally, that force is tiny and almost impossible to notice. But in the vacuum of space, where there is no air resistance, a constant push can gradually accelerate a spacecraft to remarkable speeds. This is the principle behind solar sails. Massive reflective sails capture the pressure of sunlight and use it as propulsion. Over time, they continue accelerating without consuming any fuel. The problem is simple. The farther you travel from the sun, the weaker sunlight becomes. Eventually, the push becomes too weak to make a significant difference. That limitation inspired a revolutionary idea. What if we replace sunlight with lasers? Instead of relying on natural sunlight, gigantic laser arrays on Earth could fire concentrated beams at ultralight spacecraft. These beams would provide continuous acceleration, pushing tiny probes to unprecedented speeds. This concept became known as Breakthrough Starshot. Unlike many futuristic ideas, Starshot is not science fiction. It is a real scientific initiative supported by some of the world's leading physicists and engineers. The spacecraft would not be massive starships carrying astronauts. Instead, they would be miniature probes no larger than a postage stamp. Tiny cameras, sensors, communication systems, and computers would be attached to an ultra-thin light sail. Powerful lasers would then accelerate these probes to roughly 20% of the speed of light. At that speed, the journey to Proxima Centauri could take only 20 years. For the first time in history, another star system moves from the realm of fantasy into the realm of engineering. Of course, the challenges remain enormous. At such incredible velocities, even a microscopic grain of dust could destroy a spacecraft instantly. Cosmic radiation threatens onboard electronics. Communication signals would need to travel across trillions of kilometers. Even after arriving, the probes would have no realistic way to slow down. They would race through the system at breathtaking speed, collecting data during a brief encounter before disappearing into the darkness beyond. Yet even that would change everything. Imagine seeing the first genuine photograph of another Earth-like world. Not an artist's impression, not a computer-generated image. A real picture captured by a machine built by human hands. For the first time in human history, we would look directly at a planet orbiting another star. That moment could redefine our understanding of the universe and our place within it. Perhaps the greatest significance of Proxima B is not whether it contains life, nor whether humans eventually settle there. Its true importance may be psychological. For most of history, the stars represented destinations beyond reach. Beautiful, mysterious, untouchable, but projects like Starshot suggest something extraordinary. The stars may not be unreachable, only difficult. And every great achievement in human history once appeared impossible. Flight, electricity, the moon landings. Each was dismissed before it became reality. Somewhere in the darkness 4 light-years away, Proxima B continues its silent orbit around a faint red star, waiting. Perhaps lifeless, perhaps inhabited, perhaps holding answers to questions humanity has asked for thousands of years. For now, it remains beyond our reach. But for the first time, not beyond our imagination. And sometimes, imagination is where every great journey begins.